Hi, I'm Arkangel.
I'm Siddharth, and another group member is Constantine.
Our app is SimLabs. Its purpose is to simplify challenging concepts of Newtonian physics through user engagement, dynamic modeling, and virtual labs. The app is tailored to but not limited to college-level physics students and educators. Functionality and tools. The PyGame simulation, the visuals in Python stores data about motion of objects. Then it sends the data to the web using WebSockets, Python to JavaScript. Then in the Desmos private API, data is received as data types and is stored as points within lists. The browser connection to the simulation allows for interaction based on input from either interface. We're going to be using the concept of linearization in calculus to verify a generalized formula for simple harmonic pendulum. Although this formula right here is a generalized one, the one below, which you can see, can be condensed algebraically by approximating x to sine of x.
Now I'm going to be performing one of our teaching applications. We're going to be running the code internally and straight up instead of running it on a Flask like we later on will do in the video. This is me running the file. As we can see, all the data from the simulation will be transferred here. I can use one of our pop-ups here, and this will be the graph for theta. To decrease the value of theta, I can just add an object for it to collide with. As we can see, the theta value will be getting less as the amplitude of the entire system gets less. I will end the sim now. Now I can use this data and I can run regressions on each part of it to analyze the specific period. I've already done it over here. So I have regressed all these values here. And as we can see, we have two functions. Based on the sine function and periodic phenomenon, if I take this value right here and I divide 2 pi with that value, I will get the period. I have done that for both functions. And as we can see, our period for the top one is a lot higher than what we expect. Our length of the length of the pendulum is around 400 pixels, and the acceleration gravity is like around 981. And based on our formula before, our expected value should be around 4.01 seconds. However, we notice that this approximation gets better and better as our theta value decreases. When our theta value is released all the way at 90 degrees from the vertical, it gets a lot worse. In theory, as the theta value decreases, we will be approaching our standards as sine of x, or sine of theta, is approaching theta. Thank you.
I will run the app and I will show you the login page. After logging, we can explore the Desmos Power Graphing tool. I will open the single object simulation and we can visualize motion in real time. We can see a thumb and Y position.